We're going to be looking at another quiz example, so we're constructing a straight line approximation for our Bode diagram. We are using the log paper, and I've already written out the dB and rads per second. So on the horizontal line, we have rads per second. We're going from 10 to the 0th to 10 to the first, 10 to the second, and so on and so forth, and I've also written out the actual numbers. Now on the vertical axis, when we're looking at magnitude, I color coded it, so we're doing it in blue. We're looking at decibels. And then phase, I've done in red, and that is degrees. So to start this out, we have the following equation right here. Now we need to convert this so we can see more of what's going on. We know that we can say that our S is equal to J times our omega. So we're going to do that. And we're also, when we put this in our straight line approximation, we're going to have H is equal to K times whatever zeros we have divided by whatever poles we have. And then inside of here, we have everything else. So all of this is just going to go inside of there. So if we do this, our K is 20, right? That's what's out front. That's the constant out front. So that's our K. Then we have the 100. So 20 times 100 is 2,000. And then we're going to divide this by 2,000. That's going to give us 1. So out front, we're just going to have 1. So now, since there's only 1, let's just look at what's inside. So we are going to have H, and we need to convert this in the j omega domain. In the j omega, so we're going to have h j omega is equal to, we are going to have our 1 out front, and then we're going to have j times omega plus 100, and this is all being divided by j times omega plus 2,000. Right, now I've included these notes right here, and even more can be found. A whole table of things like this can be found linked below the like button in the description. But on the left part, we have the magnitude, and on the right, we have the phase. So this is how we would graph the different things. And now we're going to combine them once we do them separately. So what we need to do is get them to kind of look like this. They're not going to look exactly like this, but they're going to look very similar. And to get it to look kind of like this, what we're going to do is multiply the top and the bottom by 1 over j omega. And what this does, it's going to give us a 1 plus 100 over our j omega, and this is raised to the n, and n is equal to just 1. And then we're going to have the same thing on the bottom, but 1 plus 2,000 over j omega, and then we have n is equal to 1. So we have this for both of them. And then again, if we had something different or we had extra stuff, we would use the other formulas. I just haven't included them here because we don't need them for this problem. But if we had something that's bigger, they would be in the notes linked below the like button. So now that we have this, let's first deal with the magnitude. The magnitude says that we go from z to our omega. So we're just going to go on kind of forever after this. And we're going to go at 20 times n decibels per decade. Now, that's really important to note. We'll come back to that in a second, but let's start graphing this out for the first one. So for the top part, we have something that looks like this, right? So now knowing that, because it's our 0 up top, we can start graphing. We're going to go from 0 to our z. Our z is 100 here. So we're going to go until we hit this point right here. That means all over here, we're going to be at the 100, right? Now after this is going to go up 20 decibels per decade. Well, remember, this is a decibel, right? And from here to here is a whole decade. So when we reach this 1000, we should be at 20 dB because we were at 0 before. So we're going to go all the way up here, and then we're going to go up another 20, and then we're going to go up another 20. And then we're just going to go until we have our omega, or we can just keep drawing it just like this for this specific graph, like that. Now we need to deal with our denominator, which is the poles. So that's the next thing. It's going to be going in the opposite direction. It's going to go from 0 to p, and then at an angle of negative 20 decibels per decade. So when we look at this, we can see that our pole is 2,000. That means we're going to go from 0 to 2,000, which is approximately right here. And I'm going to draw this in a dotted line just so we can see the difference. And then it's also going to go at a 20 decibels per decade. So it's going to look something like this. And we can see that our decade starts here, and then it goes to here exactly. Now we need to combine them. And to combine them, what we're going to do is we're going to take both of these graphs, these specific different graphs, and add them together. So to add them together, we're going to say, well, until this point, until 100, they're both 0, right? So that means they're both going to be on like this. And obviously be a little bit more straighter than that. And then after this, we have this part being added with this part. So we have 20 decibels per decade being added with 0 decibels per decade. It's going to give us 20 decibels per decade like this. Now after, I'm going to just draw it a little bit straighter. After we do this, we can see that we have 20 decibels per decade going this way and a negative 20 decibels per decade going this way. So if we add them together, we're going to get 0. And if we get 0, that means that this line is just going to be flat. So we are going to have a flat line that should be a whole lot straighter. But if technically it would be more curved, but we're just doing approximations. Bode is approximation. If we were to use a software to graph it, it would be a lot less linear. And then we can, after this, erase all of these separate graphs because the question is asking us for the total magnitude and total phase. And if we have the total magnitude and total phase, if that's what we're looking for, then we don't need this extra work right here. So now let's look at the total phase. So for the total phase, we have this 102,000. It's a little bit different. We're going to be going from Z or P, right, over 10, and then we're going to be going to Z or P times 10. So it's going to be a little bit different. So for the first one, our Z is 100, so that means we're going to be going from 10 to 1000. So that means we're going to go, and I don't want to really interrupt this blue line because I'm going to erase it, so I'm just going to go 10 above it. We're going to be going from 0 to 10, and then we're going to be going at an angle of 45 degrees until we hit our 1000. It's going to land us about right here. And we should actually go one up just because I've gone one up where it was right here to avoid the 0. But remember, this would be on here. The only reason why I'm not writing it on here is because I don't want to erase the blue line by accident. So this is going at a slope of 45 degrees, right? This is 0 degrees, 45 degrees, and then after this, it's going to continue at 90 degrees. Now we're going to do the same thing for the bottom one, but for the bottom one, we're going, we have 2,000. So we're going to be going from 200 to 20,000. Right? So let's draw this out. We're going from 0 to 200. It's going to end up about like right here. So it's going to look something like this. And then we're going to go from there to our 200,000, which is going to have us be about right here. So we're going to go at an angle about 45 degrees again, but this is a negative 45 degrees. And then here we have a negative 90 degrees. So let's combine these together now to find the total. We can see until we hit 10 right here, we're going to be going at a slope of 0 because 0 plus 0 is just 0. Now we have this whole part, which is 45 degrees, and then we have this whole part, which is just 0. So we're going to have a positive 45 degrees. That means we're just going to go up 45. I just realized I made a slight mistake right here. I drew this until 10,000 right here, when this actually is just 1,000. So let's go back and correct that mistake. We should be ending right here. So our line should be going like this, not like this. And we'll just correct this by connecting it together. So this is the line. Now remember, this is just 10 above our 0 right here because I didn't want to interfere with the blue line. But now since we're graphing it, this should just be moved down a little bit, and we're going to go really until like right here. So we're going to go from here to here, but we're going to want to go for the inflection points. And remember, the inflection is just where it changes. So it changes here, it's going to change right here, and then it's going to change here, and then it's going to change once again right here. So now knowing that, we can write this out. We can see that it's going to be going at 45 degrees until it hits approximately right here because of that inflection point. So it's just going to draw like this. And now we can erase all of this work because it's just extra work after it. Now from here we can see that we have negative 45 degrees and we have a positive 45 degrees. So if we add them together, it's going to give us a 0, right? So we can take all this out and we can go until we hit this next inflection point, which is right here. It's going to be 0, right? And then after that, well, this is at a slope of 0, right? And this is still going at a slope of negative 45 degrees. And since this is going down and this is not moving, what we're going to do is we're just going to draw this until we get to our next inflection point. And I realize I drew this a little bit too much again. I'm really tired right now, but instead of 200,000, which is what this is, it should be a 20,000. So 10,000, 20,000. Super important you know what you're actually drawing. Make sure you double check everything. And so we can just draw this out, and it's going to go again until this inflection point. So it's going to look like this. After this inflection point, it is just going to be going straight. So we have this straight and this straight. So adding them together is going to give us a straight line like this. And so this is going to be our equation. Not equation, but this is our Bode diagram. And we can use some online tools just to take a look at this. If we used Wolfram Alpha and we were to actually plug this in, it would look something like this. And we can see that the top is our magnitude, right? The magnitude is very similar to our magnitude, what we have here. And the phase is also very similar to what we have. Now, if we go on a different calculator, same thing, it's very similar. It's going to give us the asymptotical plot, which is what we want. We don't want the real plot because Bode diagram is based on asymptotical, not real. It's going to look exactly like what we have here, same measurements and everything. So we can use online tools just to check our work, but it's important to know how we got here. And so that is how we do the Bode diagram. Keep in mind, I did make a mistake when I was writing out the actual phase. I went a little bit too far. I was supposed to stop at the first part at 1,000 when I accidentally stopped at 10,000, and then I was supposed to stop at 20,000 when I stopped at 200,000. But that doesn't really affect too much, just where our lines are lining up. So it would have been a little offline if I didn't correct that mistake. But that is how you do a basic Bode diagram.